Hi, everyone, and welcome to a webinar hosted by CISQ, Automating Software Quality Measurement with Standards. This is Tracy Berardi speaking. I'm Program Manager of CISQ, and I'm joined here by Dr. Bill Curtis, who's going to deliver the presentation. And for those of you who may not know CISQ, we're a standards development organization that was co-founded by the OMG, a standards body, and the Software Engineering Institute at Carnegie Mellon University to create international standards for automating software quality measurement. That's things like software size, software quality, technical debt, and related measures from source code. So today's presentation is an introduction to the automated source code quality measures presented by Dr. Curtis, who is our founding executive director. But before we get started, I'd like to point out that the webinar presentation and the CISQ one-pager is available for download in the Handouts tab, if you'd like to take a copy. And we'll save some time at the end of the presentation for Q&A. So you can enter your questions at any time in the Questions tab, and I'll help to moderate that portion. So now, Bill, I'm going to give you control here, and we can get started.
Okay.
And thanks everybody for joining us today. Okay.
Oh, we're going to do it off my screen. Okay, just let me get the presentation up. Okay, can everyone see my screen?
Yep.
Okay, so thank everyone for coming, and Tracy, thank you for setting all of this up for us. I'm going to talk for the next 45 minutes or so on how to set up a quality measurement program using automated measures. The important issue here is they're automated because historically, one of the largest impediments to software measurement, to having a software measurement program, is the fact you had to do it manually. Well, now we have international standards for automating the measurement of a lot of critical quality measures, and so I'll walk you through how we set those up and what they are and how you can use them and what the future is of this kind of measurement. Why didn't this? There we go. We're now in the era of 9-digit glitches, and by 9 digits, I don't mean bits and bytes. I mean dollars and euros. We're seeing outages and security breaches that are costing over $100 million or over 100 million euros, and we're seeing this on a fairly frequent basis. You know, airline outages, the Delta outage a while back, they estimated at 140 million. The Target outage, or actually the Target security breach, they estimated it over 250 or 200 million. The Royal Bank of Scotland had an outage, which they estimated 175 million pounds. So we're seeing these now on a fairly frequent basis, which means that the issue of software quality is no longer an issue for IT or engineering or the CIO or the VP of engineering. It's now an issue for the entire executive team. And consequently, they're the ones responsible for governance and risk management and the protection of the corporate brand and ultimately customer experience when they're at the website or using products. And you know, when you have a major outage or a security breach, the Wall Street Journal doesn't call the CIO or the VP of engineering. They call the CEO of the company. And so these are executives who are not trained in IT, not trained in computer science, not many times not even trained in an area of engineering. And so they need help. They need a way to assess the risk to the business of the products or the IT systems that the business now runs on. And one of the things they need is measures of quality. You know, this just isn't working well. Tracy, we're going to have to run off yours. Mine simply is not, for some reason, it's not responding.
Sure. Yeah, no problem.
My system is frozen.
I'll take control back.
Okay. Okay, there we go. So we need a way to evaluate risk. Next slide, Tracy.
Sorry, one sec. You can see me?
Yeah, there we go. Okay, I'm going to kick mine down. Let me kick yours up. I don't know why this wasn't working properly. Oh my Lord. Tracy, I can't even see the screen. It's not the web. There we go. I can see the screen, but not the presentation. There we go. Okay. Okay, good. Okay.
I got that. We're back in action.
Okay, next slide. Sorry, folks. So listen, why do these software intensives fail? Why do the projects fail? And there's lots of reasons they fail. And there are things, there's processes and other things you can do to avoid failure. And click, Tracy. A lot of them involve measurement. They involve software measurement, starting with the technical risk measurement, which means let's evaluate the project and let's evaluate the software we're producing to see what kind of risk we have in that software that could cause the project to fail or overrun its budget or be delivered late. And those are the kinds of measures we can use in managing the acquisition of software from third parties. They're clearly what we can use in quality management. They're what we can use as criteria for accepting software into production or into a product line prior to putting it out in the public. So if we have automated measures, there's an awful lot we can do with it to help avoid problems in both projects and the software once it's delivered. Next slide. Another major problem we've got, especially with measurement, is that we're now dealing with a technology stack. And in the old days, if you knew COBOL, you knew the entire system because it was all written in one language. That's no longer true. A modern business application is a stack of technology. So if I'm a developer, I produce my code using my IDE, and I clean it up and I run it through some freeware that I pulled off the net to make sure it has nice hygiene properties. It looks nice. It doesn't have some obvious ugliness and smells to it. And I put it into the build and I feel like I've done a great job and I'm done. However, next click. The problem is that goes into the whole body of technology. And let's say our business logic is in .NET or Java. And so it's interacting with all of those other components. And that's a much larger challenge and a much larger problem because I've got to be able to analyze the interaction. So now I'm starting to get in the domain where I need commercial tools in order to be able to analyze all these interactions between these components in the same language. But even that isn't the big problem. Next click. The fact is we're in a technology stack. Next click, Tracy. There we go. We're in a technology stack where we've got lots of different languages in different layers of the software. And so I may have my business logics, let's say in Java, but I've got SQL queries. I'm interacting with some old legacy system that could be some kind of an enterprise management system, or it could be an old COBOL system. If I'm a bank, banks have just mounds of COBOL that still run the critical parts of their financial business. I've got a user interface written in some other language, and an API written in JPL or some other language, ASP for instance, JSP, and so this is a technology stack. And if I can't analyze the interactions across all the languages in this stack, I still don't know where my risk is, because there's risk that we have interactions that while the components themselves were correct, or that I even had correct interactions with the other components that were in the same language, the interactions across the stack where I'm interacting with different languages and different systems, different frameworks, could easily have problems that I don't know about until I can go in and analyze those. So this creates a measurement challenge because I want to be able to measure the risk of the technology stack. So these are some of the issues we've tried to address with the work we've done at CISQ. Next slide, Tracy. Back in 2010, CISQ was formed when people had gone to the Software Engineering Institute and especially to the Object Management Group and say, look, we need some international standards for software quality characteristics. The problem is we're getting these written into our contracts, things for reliability and security and maintainability and a number of other quality attributes, but there are no international standards. So every customer has a different definition of what they mean. And we can't deal with that. We need some international standards, not 75 different definitions of what security is or what reliability is. And so Paul Nielsen at SEI and Richard Soley at OMG got together and said, look, let's form a consortium. Since I'd worked with both of them, they asked me to become the founding executive director, and we created CISQ. And the objective of CISQ, next click, Tracy. The objective was to create automatable measures for software systems, automatable measures for both size and for structural quality, things like reliability and security and performance efficiency and what have you. And gain approval for these as OMG standards, which made them an international standard supported by the Object Management Group, which has a large number of international standards, things like UML and Corba and a number of other software-related standards. They also have a fast track to ISO, and 2 days ago we got our first ISO standard. I'll tell you more about that in a minute. So we're now supported by a number of sponsors who provide the funds that help us run our programs and support our website and the other activities that CISQ is engaged in. We have a number of partners who we interact with, and we support their conferences, they support our conferences, and so we've got some mutually beneficial relationships there. We've just added a new director. I've been the executive director for a decade, so I'm going to step back, and we're bringing in David Norton as the new executive director of CISQ. And David has enormous contacts across industry, having been a Gartner analyst for many years. And so David's going to lead the charge to get the standards we've produced deployed out into use into companies, into government agencies, and what have you. So I'll kind of step back time-wise and still do some technical work, but David's going to lead the deployment activity and try to help drive this into international use. Next slide, Tracy. We held executive forums to start CISQ in Washington, D.C., Frankfurt, Germany, and Bangalore, India. And we've kind of had a voting process for what measures would you want us to create standards for if we form CISQ. And these were the 5 measures they chose. 4 that dealt with quality characteristics, and you can see automated function points. They said, frankly, we're tired of the cost of manual counting and the inconsistency across different counters. If you could automate that, we would consider that a tremendous benefit. Next click, Tracy. And so we launched CISQ. We had enough support to launch it. We developed specifications for automating each of those. They were presented to OMG. They went through the OMG process, which is fairly rigorous evaluation, and they were approved as international standards. You can see sort of the OMG standards there on the right. Those are available free both on the OMG website and on the CISQ website. We're beginning to fast track some of these standards over to ISO. I'll show you more about that in a minute. And we're engaging in deployment workshops and other activities now to try to deploy the CISQ measures throughout industry and through government usage. Next slide. The first major standard that we produced was automated function points. It's a size measurement. David Heron, who's recognized as one of the gurus in the function point world, he's one of the co-authors of the best book on the topic, Function Point Analysis, led that group. And he had a group of 8 people that represented the US, Europe, and India. They worked diligently for a couple of years to create the specification, had it reviewed by a number of people, and it then in 2013 became an OMG standard. It has been submitted to ISO. Next slide, Tracy, or next click. It is now an ISO standard. 2 days ago, we found it had been uploaded to the website as a standard approved by ISO. ISO 19515. So the automated function points is now an ISO standard. There is commercial support with tools for being able to evaluate the function points in a system in an automated way. So I encourage you to consider the standard. If you've chosen to use function points as a size measure for your software, especially for business software, I encourage you to investigate the use of automated function points and the various vendors that are beginning to support that. So that was a major success for CISQ, and I think it really did a lot for helping support function points as a size measure, as a legitimate size measure, by reducing the cost, because now it's automated, and by reducing the inconsistency. There's still a role for manual counters because there's estimating up front before you have the software, and that's where their role comes in to help estimate, the size of a system. But for actually evaluating the system once it's built, we now have an automated way to do that, and David himself has done some studies to show that with work you can get the automated count and the estimated counts to be very close, within 5%. But the nice thing with the automated measures is you get the same one every time if you're measuring the same piece of software. Next slide, please. Our structural quality measures, and these 4 measures are now OMG standards, have been developed for security, reliability, performance, efficiency, and maintainability. Originally, when we had those approved as standards back in 2016 and 2017, they were just for IT software. We had focused on that. There was a request that we upgrade those for embedded systems because of the growing impact of the Internet of Things and of embedded chips in all sorts of devices, especially safety critical devices like medical devices, avionics, nuclear plants, and what have you. So we have upgraded that. We've just had approved our upgraded measures for these 4 quality characteristics. You can see in the number of weaknesses, these are basically built out of counting the number of weaknesses in a particular piece of software. And these aren't all weaknesses. They're just the ones that the people building the measures felt you absolutely had to remove from the software within the next several releases. So let's look at security here. You can see there's 36 weaknesses. In parentheses, there's 37. We, in fact, developed a way, and we really borrowed this a lot from the Common Weakness Enumeration, to look at a parent weakness that's sort of the general case, and then there's many instantiations of that, many different instantiations of the way that weakness presents itself in software. And so in parentheses, there's the children of the various parent weaknesses. So for instance, for buffer overflows, which is a major security problem, there's a weakness number 119. That's sort of the general statement of buffer overflow, but there's 12 different ways that a buffer overflow can occur, and those are the child weaknesses. So we list a parent weakness, and for that one we list 12 child weaknesses that represent the different ways that a buffer overflow can be instantiated in software. So we have this parent-child relationship, which gives us roughly about 120 total measures, or I think about 97 that are unique, plus the children weaknesses. You can see here in the middle column examples. So for reliability, you can see the weaknesses we're looking at are things like poor exception handling, deadlock, improper synchronization, things that will crash the software or make the software difficult to recover or cause other kinds of reliability problems. And so this isn't all possible reliability or performance efficiency or maintainability weaknesses. It's the one that the folks building these measures felt were most critical, most severe, and had to be dealt with, had to be removed at some point from the software in order to reduce the operational or cost risk. So that's how the CISQ measures were created. An important recent development, Bob Martin, who's been very involved in the creation of the Common Weakness Enumeration up at MITRE, which is supported by the Department of Homeland Security and the National Institute of Standards and Technology, has assigned CWE numbers, or had CWE numbers assigned to all of the CISQ weaknesses. So these are now in the Common Weakness Enumeration repository, which is the world's largest repository originally of security weaknesses, of ways that weaknesses hackers have exploited to get into the software. They're now expanding that to other quality issues, and they've incorporated the other CISQ problems of reliability, performance, efficiency, and maintainability, and all CISQ weaknesses have now been assigned CWE numbers. So that integrates this into a globally used body of known weaknesses. This also is a standard through through the United Nations ITU Standards Group, they've accepted the CWE as a standard for listing these weaknesses and the numbers that are assigned to them. So we have that level of standardization with all of these weaknesses. Next slide, please. This is just an example of, in this case, a couple of CWEs in the area of security and their child weaknesses. So over on the left-hand column, you can see the CWE number assigned to each weakness. If it's in a dark blue area, that's a parent weakness. If it's in a light blue area, like CWE 23, that's a child weakness. So we have improper limitation of a path name to a restricted directory as the parent, and it has two children, a relative path traversal and absolute path traversal. So those are two different ways that this weakness can be instantiated in software. So where we know that there's child weaknesses are different, really basically different instantiations of the way a parent weakness can be can occur in software, then we've included those in the CISQ the CISQ weakness list. And so you can see over here on the right, notice that second bullet, we list the United Nations Standards Body's assignment of a number to the CWEs, and so this will be a part of that standard. Next slide, please. This is the number of both parent and child weaknesses that we have created in the standards. You can see the number of previous weaknesses in the old standard when it was just IT. So you can see we've upgraded these. In some cases larger than in others. We've more in reliability, security, and maintainability. We really only added one in performance. Plus we've added some child weaknesses. So, but we have upgraded these in the area of embedded systems to bring in some of the problems that we see in embedded systems. One of the interesting observations that was made by the team of experienced embedded systems developers when we started this process of updating the weaknesses was that they said they are putting so much functionality on the embedded chips that they're basically look like more and more like IT systems. More and more of traditional IT functionality is now being embedded on the chips themselves. So they found that most of the weaknesses we had already listed for IT software were also relevant for embedded software because of the amount of functionality now being shifted onto chips. So we've added traditional IT functionality plus the weaknesses that are more specific to embedded systems and the kinds of problems you have when you're trying to build software to run an embedded chip as part of an overall Internet of Things system or an embedded product. Next slide, Tracy. Do these measures predict problems? And the answer is yes. So we've got a number of studies like this. This was a major system integrator in Europe. They looked at 21 systems that they were managing on behalf of their customers, and they looked at what they called a total quality index, which basically adds these four CISQ measures together for reliability, security, and just gets an overall measure of quality that incorporates all of those measures. They correlated that with the number, well, actually with the log of the number of incidents they experienced in the system, and the correlation was very high. It accounted for 1/3 of all the variation in the log of the incidents, the number of incidents. So that was a very strong correlation. It ended up that quality accounted for a great deal of what they were seeing in the incident. So these measures do predict. They are good measures of risk, and so that's one reason we recommend them for using not only in the quality, but also as a measure of the risk to the business presented by the IT or embedded systems. In fact, in this particular study, they said they got to the point where they realized that if they could improve the quality score, and you can see they've got basically a 1 to 4 scale. If they could increase it by 0.24, they could cut maintenance costs by 50% because the software was so much easier to work with, especially when you look at maintainability. Changes in maintainability have a tremendous impact on the cost of working with software. Next slide, Tracy. Based on having these measures of structural quality, we can actually evaluate the number of weaknesses in a piece of software and then get a measure for the quality of the software based on that. We can also get a measure of the cost of corrective maintenance. Let me kill my email system here. We can get a measure of the cost of the corrective maintenance, which is technical debt. There are a number of different definitions of technical debt. The original definition Ward Cunningham created in 1991 was that if I just have to get the software out quickly, I go ahead and make some design decisions I know are suboptimal. But I know at some point I'm going to have to come back and fix that suboptimal design decision, and it's going to cost me money to do that. It's going to have to pay for the effort to come back and fix problems I knew I created in the software in order to get it out fast. Well, frankly, CIOs don't care what the reason is, whether you knowingly created a suboptimal design decision or you just made a mistake. What they know is they're going to have to pay for fixing it. And so the technical debt measure that we accepted, the definition is that it's any time you have no defects in the system you know you must fix. That's technical debt because you know you've got to pay to get those defects out of the system. Click, Tracy. So the first aspect of technical debt is the principal, which is the cost of removing these defects from the system. And then there's the interest on the debt. Until I get them removed, it may cost me extra. For instance, if it's a maintainability issue, if it's a maintainability issue, it's going to cost me extra time and effort for people to work on the software. It's just that much harder to work with. If it's a performance efficiency issue, it could be costing me extra cycles, which if I'm in a cloud environment, I'm going to be paying for those cycles. I may even have to have more capacity. If I'm not in the cloud, I may still have to have more capacity locally to handle all of this inefficient software. So that represents interest on the debt. Next, click, Tracy. If I have an outage or a security breach, that's a liability, and that's liability on the debt until I get those security-related or reliability-related weaknesses removed from the software. And in addition, the more time I have to spend fixing problems, the less time I can have to add new functionality into the software. So that's a lost opportunity. I'm losing business opportunity because I have to spend time correcting these severe defects. So the nice thing about the technical debt metaphor, it gives us a way to talk to the business in business terms. Why does software cost so much? Why do we have to spend money in this maintenance correction activity? Well, here's why, and we can put numbers to it. The business has to put the lost opportunity numbers. They have to estimate the liability numbers, but gives them a way to understand what the risk is of poor software. So we had professional developers estimate the amount of effort it would take to fix the various CISQ weaknesses, and that gave us a measure of allowed us to estimate the overall effort to fix particular weaknesses that could be in the software. Next slide, Tracy. So I've got this basic estimate of what it would take to fix each instance. We can adjust that by the difficulty of the software. If it's a complex component, if it's coupled to everything else in the system, there's all kinds of ways it could take longer than the estimate that we got from the developers, and we can go analyze the software and see if we need to add additional effort in based on coupling to the system or complexity of the component or what have you. And so I look at a particular weakness, let's say SQL injection or cyclic dependencies or what have you, and I can count all those instances up and then add up all the efforts to fix each individual instance based on its complexity or what have you, and that gives me a total effort to fix that particular weakness. Next, click, Tracy. Then I can add all of those up within each of the quality characteristics. I can add up all the reliability weaknesses, all those efforts to say, what's it going to cost me, or what effort is it going to take to fix all these weaknesses we have in the area of reliability or in the area of security, and get a total effort. And then I can add all of those up. Next, click, Tracy. add all of those up to get an overall estimate of the technical debt, which is the effort to fix all of these weaknesses that we know we have to remove. I can then put dollars or euros or rupees or whatever your currency is to that to get an overall cost estimate of what it's going to take for corrective maintenance if I want to remove these severe weaknesses in the software. That's now an OMG standard. We're going to have to update it now that we've updated the list of weaknesses for embedded systems. We're going to have to update the technical debt measure, but at least we have one for the IT related weaknesses. Within the next year or two, we'll have updated the technical debt measure to include the new weaknesses that we've added in. But that gives us a standard way to use the CISQ weaknesses as a way to estimate what your corrective maintenance costs are going to be. Next slide, Tracy. This is our roadmap. You can see I've pretty much talked about all of these except automated enhancement points. We found out with function points that when you're trying to do productivity analysis in a maintenance or enhancement environment, function points does not estimate the size or count the size of the non-functional code. In a modern business application, that's almost always over 50% of the code. And so if all of your work was on non-functional elements of the application, from a function point of view, it looked like you didn't do anything because that's not sized. So we created a measure called enhancement points. I'm not going to go into much depth on it now, but it basically allows you to count both the functional code and the non-functional code, translate that into a measure, combine it into a measure that looks like function points, and use that for things like productivity analysis during an enhancement or maintenance activity. So those are the work we've done to date. Next click, Tracy. We've done a lot of work to make sure that we incorporate those into international standards, that we stay consistent with the international standards that exist. I'm going to talk more about the ISO standards in a second. Next click, Tracy. And these are the where we're going. This is what we're going to be doing in the future. We're going to add some additional work in measures, but we're also going to focus on getting these measures deployed into acquisition, into risk and cost measurement, into management, into showing folks in the Agile and DevOps world how you can incorporate these into a DevOps tool chain and use them in a way that doesn't take lots of time away from developers, but provides developers with lots of valuable data about issues that they may want to add into the backlog and address in future releases. And I'll talk about a certification program in a moment. We are just now launching an effort on taking these weaknesses up to the level of model-based software engineering, up to the level of design, which is especially critical when you get into regulated systems, life-critical systems like medical devices, avionics, nuclear systems, and what have you, because they're required to do work at the model-based level, and we're now looking to see if we can take the CISQ measures and define a set out of that that's relevant to the model-based level, to the design and architectural level, that can be used as measures of quality at the design level, where you have formal representations of systems in UML or AADL or SysML or one of the other design languages that has a formal syntax and semantics. We can at least evaluate that in an automated way and take measures of known problems at the design and architectural levels. That's a major effort we're launching, in addition to the work to get these deployed into use inside corporations and government agencies. Next slide, Tracy. This is our commitment to ISO. We made sure that the definitions of the 4 quality characteristics that we developed standards for were consistent with the definitions used in ISO 25010, which defines the software and system product quality model. You can see in the light blue there, those are the 4 areas that we have defined standards for. and they are consistent. We use the subcharacteristics under each of those 4 areas to help us make sure that we covered that domain to the extent that the subcharacteristic is measurable. Now, I'm the American lead to the ISO 25000 series, and we now have 25010 under revision. Some of the biggest changes you'll see in operability is going to become roughly the equivalent of usability. There's been a lot of work on that. We're going to add fail-safe or safety into reliability. Portability is one of the areas of biggest change. We wanted to make that more relevant to the modernization efforts going on around the world. That'll become flexibility. Portability will become a subcharacteristic. We're adding in scalability. So the goal is to really make that as relevant as we can to the all the modernization work being done on upgraded systems. However, next click, Tracy. The international standard that defines the measures is ISO 25023, and unfortunately it doesn't get to the level of source code, so you can't automate from 25023. I've tried to get those kinds of measures in it, have failed miserably. The measures in 25023 are really at the behavioral level, so it's things like for reliability would be availability or downtime, not things like poor error handling or deadlock that'll crash the system. And so the CISQ measures supplement ISO 25023. It gives you the next level of measurement below those measures defined in 25023. Now, 25023 will undergo a revision activity once we get 25010 approved, its revision approved, and at that point we'll work to get things like the CISQ measures and AutoSAR and other collection, MISRA and other collections of weaknesses at least referenced, the source code weaknesses referenced, and then hopefully have appendices that describe those sources of weaknesses at the software source code level. And the CISQ in particular have become international standards for measuring those weaknesses. So it supplements 25023. Next slide, Tracy. This is the NIST cybersecurity framework. It's becoming very popular not only in government, but we're seeing increasingly being adopted in industry, especially in regulated industries where there's government regulation. It really provides a process for managing the security of your systems, of your IT systems, and other issues related to that. The CISQ measures support this. Next click, Tracy. These are 7 areas where you could apply the CISQ measures, both size and quality characteristics, especially the quality characteristics, in conducting those processes. They support the processes. They give you the measures you need to really to effectively execute those processes. So we're working with things like the CISQ, the NIST cybersecurity framework to make sure that you can deploy the CISQ measures in a way that supports some of the major frameworks that are being adopted both in government and in industry. Next slide, Tracy. Now that executives are responsible for big crashes, big security breaches, and the risk to the business those create, they're going to want a way to show they're doing their due diligence, and partly that can involve certification. I want to certify the level of quality in my software so that I can show I'm doing my due diligence, and if the software is not up to our risk tolerance standards, then I'm going to require corrective action. So CISQ will not do these certifications, but we will endorse technologies that can demonstrate they can detect the CISQ weaknesses. They will become CISQ conformant, CISQ endorsed technologies. Next click, Tracy. And if they have either vendors or the vendor themselves can do the analysis, and they have people trained to use the technology, then they can go out and perform a CISQ conformant certification activity. Next click. And basically they can provide some kind of a certification of the current state of the software. You know that certification is not valid the first time you make a patch, but what the real issue here is to show that you're doing your due diligence. And so I see this more as something executives are going to want to show that they are periodically evaluating the risk to the business and then doing what they have to do to manage that risk if it's not up to an acceptable threshold. So this is one way that the CISQ measures could be used in a certification process performed either by the technology vendors or by, for instance, a system integrator that's trained to use the technology in their quality business. Next slide. Okay, this really describes the work I described earlier about model-based software engineering. I'm going to go through this fairly quickly. Yeah, go ahead and click through, Tracy. The goal here is to identify weaknesses at the architectural level that you can detect from basically a design stated in a model-based system engineering language or software engineering language that you can then go ahead and do the analysis and create the measures. And so there's sort of two kinds of measures. One is the quality of the architecture and design itself, and the other is the quality of the model of the architecture. Does it have the components that it should have to be a thorough model? So that's work that's currently just initiated with CISQ. Next slide, Tracy. We've created a trustworthy systems manifesto. The manifestos that are out there today were really written by developers. So they state the issues in terms that are relevant for developers, not in terms that are relevant for the business. And so executives need to understand what they should expect, what they should demand from their engineering or IT organizations. And so that's what the Trustworthy Systems Manifesto does. It states 5 principles that executives should use to create a conversation between the executive team and either the IT team or the engineering team to say, what are you doing in these 5 areas to reduce the risk to the business? You know, what kind of engineering discipline is it sufficient in both product and process to reduce the risk? What are you doing about ensuring that the quality of the software we're putting out in our products and in our critical business activities, it is at least able to perform to the level of risk that the business can tolerate? Do you know where all these system components are coming from? Do we have license issues? Do we have vulnerability issues? You know, where are these systems, these components coming from, and what do we know about them that present risk to the business? Obviously, proactive defense of the system and its data, the security issues, and at the end, reliability and safety issues. So this is on the CISQ website. It's available for you to read. There's more detail about each of these 5 areas, and we encourage you to read it and sign it. So this is the CISQ website. Membership is free. Anybody anywhere in the world can come join CISQ, join and get access to the standards, to the blogs. We have examples of language that you can use in system acquisition and, you know, in contracts and statements of work, RFPs and what have you, that you can use the CISQ measures as part of that. So there's a lot of material here. We're trying to make this a go-to website for issues and information on structural quality. You can see we've got, these are sort of some of the companies that individuals have come and joined CISQ from. So we encourage you to become a member of CISQ. As I said, it's free. You can see the URL for the website up there in the title line. So with that, let me turn it back over to Stacy, and we can open the floor for questions.
Sounds great. I know we covered quite a bit in the webinar today. So if you have any questions, you can go ahead. There's a in the GoToWebinar toolbar, little questions tab. There was one that came in earlier about you know, the recorded session. Will it be shared? Yes. Yep. We're capturing a video of this, and what we do actually with all the webinars is post the video and the PDF download, you know, to our website. So later on, if you want to hop over, you'll actually get an email, but if you want to go sooner on our website, if you go to the events calendar, you can find the webinar page and the recorded session. But Bill, it looks like actually light on questions. So I guess you were or comprehensive.
Yeah, I do talk fast, so people probably have to catch up and come up with a good question. Look, this work is going to continue, and our big issue now is getting these standards deployed. They exist, they're available. We've seen them used in some government contracts. The French government requires you to report the size of a system you're building for them in automated function points. There's a number of U.S. government agencies that have written CISQ into their RFPs and are starting to use those as a way to evaluate the software that they're getting from their contractors. So we encourage people to use this both for managing internal quality, the systems you're building internally, as well as for using in software you're acquiring from third parties. In fact, you could even apply it, we encourage you to apply it to the freeware, the open source software that you might be incorporating into your IT systems or into your engineering systems.
Mm-hmm. And I'll mention, if anyone is looking, and now some questions are coming in, so there we go. But I'll mention on that subject, if you're looking for samples, we have plenty now, both on the development side, how to use these internally on your projects to build better systems, and then on the vendor management side, sample RFPs, contract language. So feel free to send me or Bill an email.
Tracy, real quick, tell them how to become a member. Show them or tell them what they need to do on the website, what they need to click to become a member of CISQ.
Yeah, so and now that we have this slide up, so this is the CISQ homepage that you're looking at. The easiest way, see in the top left, there's a button for membership. You can click that. There's two levels. There's a free individual membership, and then there's also a corporate membership level, depending upon how involved you want to be. Corporate member companies contribute to the standards development, can join various working groups that Bill helps to lead. Also take a larger presence at some events that we organize in terms of speaking opportunities and interviews. We do a lot of analyst briefings as well too. So there's a couple of ways to join. So it'd be great. Yeah, you can just click membership and join our community here. So Bill, we have a few questions that came in. First, is there a plan to align CISQ with OWASP? Have any conversation?
Actually, it's sort of already done. We incorporate the OWASP weaknesses into the security measure. Originally, we took the top 25 CWEs, of which the OWASP top 10 were a part of that, and the SANS Institute top 25. But we expanded that, when we expanded this to the embedded world, we expanded the list of weaknesses, and one of the things we looked at was OWASP, the OWASP top 10, to make sure that we had those weaknesses incorporated into the CISQ standard, and that's for the security measure.
Great, thanks. Next question. Since thousands of software firms are small or very small, are you going to provide tools to help them apply the automated measurements?
Yeah, CISQ itself won't build tools. We're a standards organization, but the standards are available for free. Unlike ISO and some of the others, these are free. All OMG standards are free, and so vendors can pick these up and incorporate them into their technology. You can in fact see two of the vendors support CISQ: Synopsys with their Coverity tool and CAST with its application intelligence platform tool. So there are vendors out there working on incorporating the CISQ measures into their technologies, and so you can really evaluate the vendors to see which one might fit your needs most effectively.
Right, and I would add that with this, the updated quality measures, all having a set of weaknesses that map to the CWEs, it's easier to take a look, under the hood there, in terms of, the tool that you're using and the weaknesses to, look for in the the code and architecture. Next question from our friend Herb Krasner. Hi, Herb. Bill, can you say a little bit more about our new project, model-based engineering? Can you say a little bit more about the model-based architectural weaknesses?
Well, we're just starting that. We literally had our first meeting last week in Washington, D.C. And consequently, we went through the existing weaknesses in the CISQ measures to see which ones could be potentially design weaknesses as well, or detectable in a design model. And now we're going to start reviewing a number of other collections of weaknesses that are out there at the design architectural level to start pulling some of those into the CISQ measures. The real issue is it has to be a weakness that can be detected from one of the various modeling languages, that it would show up when you build a formal model of the system in a language like UML or ADL or SysML or any of the other modeling languages. There's a number of tools out there that are very good in the model-based software engineering space that do build formal models that these could be analyzed from, and then we would go back to the standard way of developing measures from that we've used in CISQ, which is the count, which can then be translated into density if you divide it by the size of the system. Now, determining the size of the model is going to be interesting, so we're going to have to see what it would take to turn that into a density measure. But that's where we're going, is trying to now, having looked at the CISQ existing weaknesses, we want to look beyond that to other collections of weaknesses at the architectural level. For instance, we'll go through the CWE, the full CWE, to see if there's a Common Weakness Enumeration repository, to see if there's other weaknesses that we can incorporate at the architectural level.
And then this final question is, how can I participate in that working group, the model-based systems engineering?
Basically the people that participate are the folks that are supporting CISQ, that are sponsors of CISQ. We will occasionally put things up on the website and ask for comment, and giving us reviews is a very valuable way to participate, getting a review back to say whether you think the things we're incorporating are the right things, the wrong things, there's things we've missed, what have you. So, you can become a sponsor of CISQ and directly participate, or you can wait until we post something on the CISQ website and ask for a review and then participate as a reviewer.
Yeah, and when I was pointing out the membership button in the top left, so that goes back to the two levels of membership that I mentioned. If you are interested in joining at that corporate level and helping to sponsor the work that we do, then that enables your organization, your team members to join various working groups that we have. So if you want to talk more about that, happy to do so. Any other questions? It looks like we answered the ones that are currently in the queue. And again, the presentation download is in the handouts tab. There's Bill's slides. We'll get the recording up this afternoon too. This will also be emailed to you. Stay tuned, because later in June, and it looks like he's on the webinar too, we're going to have our friend John Marion from MITRE to present some new research that he's doing on government IT systems, their vulnerabilities. It'll be interesting. So yeah, that's another good reason, I suppose, to join CISQ, and we'll send you some more invites along these lines.
Yeah, John's going to show you how you can use measures, automated analysis, using these kinds of measures on large systems, and he's done this across a lot of systems in the federal government. And he's going to show you the kind of results you can get and the kind of analyses you can perform, and even the kind of benchmarks you can develop based on this kind of structural analysis of the software, automated structural analysis. Great.
Okay. Looks like we're ready to wrap up. Thank you, Bill. Thank you, everybody, for hopping on. I hope you have a great rest of the day, and we'll see you again soon.
Bye-bye.